All right, good morning, everyone. Today we're going to be talking about constraints and relationships. In constraints, we'll be covering what and why constraints. We'll be covering primary key constraint, the unique key, not null, check, and foreign key. Some of these we've already seen in action, but we'll go into why we have them and what the uses of them are. And then afterwards, we'll go into talking about relationships, how to identify a one-to-one relationship, a many-to-one relationship, and a many-to-many relationship, how those relationships are established, enforced, and maintained. Does anyone have any questions over what we'll be covering today? All right, no questions. Just a friendly reminder, if you do have a question you would like to type it into a chat, please type it into the Whiskey Questions channel. All right, moving on, we're going to look at constraints in Postgres. So, what are constraints and why do we need them? Well, we've talked about this a couple of times before, and during our intro to PostgreSQL lesson during our full stack week, we also talked about the importance of maintaining data. Now, Postgres already does a considerable amount of ensuring that the correct data is being inputted into the database. But it's not doing all the work for us, right? For example, if we wanted to take in an email from a user, we wouldn't be able to specify within Postgres, hey, this is an email and only an email should be accepted here. It doesn't have that capability, right? We would have to write some sort of check to ensure that every email or every entry for that database has an @ with a follow-on valid Gmail or valid email address that we can find. So there's a couple of things that we can do to make sure that things go into the database correctly. And that's what constraints really allows for us to utilize. It also allows for us to enforce that something will get entered into the database for specific fields, that things can be unique, so they can be uniquely identified or information won't be repeated. And we also have our primary key constraint, which we talked about yesterday, which is going to be our main identifier so that we can build our relationships from one to another. Does anyone have any questions about what are constraints and why do we need them? All right. So the first constraint that we'll be talking about is going to be the primary key constraint. So the primary key constraint, what it actually does is it gives us a unique identifier for each individual entry inside of a data table. We've seen that quite a bit. We have a real world example here that we can cover real quick. So consider a scenario where a table stores information about students. The student ID column serves as the primary key, ensuring that each student is uniquely identified by their student. So even though we don't have a unique argument inside of that primary key constraint, it will ensure that it is always unique. And if any entry types should come in that is repetitive, it's going to throw an error. So here we can see the table. It's create table students, where student ID is the primary key, and student name takes in a variable character of 255 characters. Now we've already created that in our database as well. If I run select all from game, we can see that I have a game ID, right? And for that game ID, I have a primary key, a serial primary key that's being provided for me for each individual entry. Each one of them is unique. We can see that where it goes from number 1 all the way to number 10. Notice that 0 was never an input. So we know that primary keys start from 1 and then go incrementally up. They do not start at 0. And there's one unique entry for each individual item. So if I try to enter data into this database with the same key, it's going to throw an error. All right. Does anyone have any questions regarding primary keys? Okay. So the next one we have is a unique constraint. So the unique constraint is it's pretty self-explanatory. It's in the name, right? That's the one thing I really like about SQL is that it's almost plain English. It ensures that every single entry within that field or that spot that you gave it a unique constraint to, it will always come in being unique. There is not going to be any repetitive values. A perfect example for that would be an email address, right? No one person should have, well, no, there shouldn't be any entry of the same email address. Why? Because even when you go to sign up for an email, you have to go through the trouble of figuring out a certain number of characters to make sure that your email is unique. It ensures that there is a one-to-one relationship between an email and a person. So now we enforce that by making sure that it's unique so that when users sign up for our application, we can make sure that each user has one unique email that belongs to it. All right, so here we have our user ID, which is a primary serial number. There is a username, and then we have our email. And we can see that the email uses a variable character that is unique. And this will get extended as we move forward. All right, the check constraint. So the check constraint is going to be one of the more usable ones and common ones that we'll see using more over and over again. And the reason behind that is because it lets you write actual logic to ensure that something fits the entry that you wanted to admit, right? So here we have a check constraint for an age limit. So in a database managing information about movies, a check constraint can be applied to age column to ensure that viewers' ages are within a specified range, all right? So before we take a look at that, let's go ahead and try to create this table on our own, get a little bit of practical application here. All right. Would anybody like to walk me through creating a movies table where we could take in a movie title and maybe a client, an appropriate age?
Yeah, I can do it.
All right, let's go through it.
So the first thing you want to do is just create a table and then whatever you want to name it. So in this case, probably movies or movie, whatever. And then you're gonna want to do a unique ID per movie. So it'd be like movie ID, and then same thing, serial primary key. And then we'll need a name for each movie. Um, So you could, yeah, just movie name or name. And we'll just do a var char for that with whatever character limit sounds good. And then we'd probably just do, yeah, I think then we'd probably just do the check constraint for age to make sure they're old enough to watch the movie.
All right. So now we have our movie name, which I think we would also want this movie name to be unique. All right, so let's go ahead and add that constraint in there. We want a unique movie name, a unique movie ID, and then we want to check the age limit, right? Or just age. Maybe I'll change this to age limit so that it's a little bit more specific. Well, now I could add the constraint. I could say check, and I could tell it that I wanted to check if age limit is greater than 18 and age limit is less than 100. All right. And let me go ahead and do a little indentation there. Okay. And just like that, I just created a movie ID, a movie name with a unique name, an age limit, which will take in an integer, and it will check that the age limit is greater than 18 and that the age limit is less than 100. So if I tried to insert any data that wouldn't fit these parameters, it would throw an error. Does anyone have any questions regarding how we created this table here or how the check constraint works? Go ahead, Jose.
Actually, I was just wondering on your syntax or like how you laid it out. Do you commonly enter and tab for the check, or is that you just what you did now?
Yeah, so the reason why I entered and tabbed in here is because I wanted to make sure that this is recognized as part of the age limit, right? I could definitely have it all within one line. But for me to be able to compress it, so for example, if I do this, right, and then you can't see it, well, I would want other developers to be able to recognize, hey, maybe I have multiple conditions that fall into that age limit or other constraints that I want to apply to that age limit. Instead of having it all run in one individual line, I'll just simply indent them and enter them so that everything can follow through. Does that answer your question?
Yep. And then with that follow-up, so that means that we can have multiple check constraints, or is that just different constraints inside the parentheses? Like just keep doing and then you add another one.
Yeah, you could have multiple constraints. So for example, not in this case, right? But if we wanted to, we could also make this unique. Maybe this takes in some other form of constraint that we could apply. So we want to make sure that this is not null. Right? And just like that, I have multiple constraints that fall into one specific field. Does that make sense?
Yep. Thank you.
Of course. All right. David?
Yeah. Do you have to have the greater than and less than, or can you have it just check age limit greater than 18?
Yeah, you could definitely just have it check one greater than 18. But if I wanted it, so this is all just going to evaluate to a true or false variable, right? So whatever conditions I pass into it, if there's multiple, I could pass an and, I could pass an or I can do something like age limit in 18, 19, and 20. And it would check if the age limit is one of these three. Does that answer your question, David?
Yeah, thanks.
Of course. There it is. All right. And I see a question on the chat here. So Adrian brings up something. He says, if I remember correctly, yesterday Landon said if we have utilized unique, we should use drop table. Is this something that's common practice? Huh. You want to speak on that, Landon?
Yeah, if you it was when you include foreign keys on the tables, and you build out multiple tables, you're not going to be able to just drop a table that has that linkage across the tables. So right now, since you don't have any more tables, there's no foreign keys. You could drop the movies table, no problem. But if you add more tables, and when we add in foreign keys, you're not going to be able to drop it straight up.
Yeah, definitely. We'll be covering all the foreign key relationships and tables dependencies on other tables here shortly once we go into the second portion of our lecture. But currently, we're still working on one individual table without associations or relationships. Good catch, Adrian. All right. Let's move forward with our scenario here. The next thing that we have is the not null constraint. The not null constraint ensures that a column does not contain any null values. It enforces the presence of data in the specified column. All right. So not null is just going to make sure that every time we enter a field entry, there's an actual value here. Serial primary key, that will be generated for us if we don't provide one. And if we do not provide one and it is not generated for us, so let's say we're copying straight from a CSV file, then in that case, it will throw an error saying, hey, you need to make sure that you're providing a value for serial primary for the movie ID. Otherwise, it's violating a not null constraint. We have our movie name here, which we added unique, but we want to make sure every movie also has an actual name. We don't want to accept entries without it. So we want to add that not null constraint. And same thing with our age limit. We want to make sure that there is a not null constraint. Right? It's not going to be unique because we know that every movie could have maybe the same sort of constraint depending on their rating. But the movie name should be unique and age limit should also be not null as well as movie name. And then we have a scenario. So in that scenario, it says in a database managing inventory, the quantity column in the products table may have a not null constraint to ensure that each product entry has a defined quantity. So if you're running some sort of store, right, you wouldn't want to remove that entry once you run out of it, especially if you're going to restock, right? So you would want to keep one in stock all the time so you could display it. And then you would want to make sure that that field stays in there so that when you go and you restock on that specific item, you can update the quantity. And if you're truly removing it from your inventory, then there's no reason for that entry to exist. So might as well just completely remove it. So by adding the not null constraint, we're making sure that there's always going to be a certain value for quantity. And if that quantity value goes away, then we would just remove that entry. Right? Every single thing that gets entered into the database will always have an actual quantity because we're adding that not null constraint. Does anyone have any questions over not null and check? All right, it doesn't seem like there are any questions. So let's go into applying these constraints into our database that we created yesterday. So applying constraints. We're going to take a look at our game table within our store SQL file and add some constraints. So here's our store. We can see this is my final product from yesterday's assignment. I was able to create a table for each one of the CSV files passed on to us. And I'm able to load all of this data and run this SQL file successfully. All right, but now let's take a couple of things into consideration. So the game ID, we have a primary key that will remain unique. So here we can see our integer primary key. Oh, that's it, wrong one. Here we can see our integer primary key. But what about our game title? So usually game titles are unique, right? They don't necessarily always repeat themselves. And if anything does change within a game title, or if it's for a specific system, it's going to tell us, hey, this is version 2, or it's going to tell us, hey, this is the extended version. So we know that we could update our game title to make sure that it is a unique constraint, right? And we'll apply all of these here shortly. We can see that our quantity, we talked about quantity just shortly. So if we completely run out of it, why have it? So we can maybe add a check. And we have our price. So our store is committed to low prices, but it is not committed to charity either. So we should make sure that our cost is always above $10, but always less than 60. Okay, so taking it one step at a time, we have our integer primary key, that's checked off. Now our game title. What could we add here into our game title to ensure that we fit the requirements in this statement? Does anyone have any ideas?
The unique.
Okay, so let's add a unique constraint. What else? Should we accept entries with a null value for a game title?
No, it would need to be not null.
So let's go ahead and add that not null. All right. So now you look at the provided CSV data, we can see our game titles are in a title format. They have characters and numbers within their string, and they accept a special character. Huh. So that sounds like some sort of check that we can do, right? If we were working in Python, we could do something like python.title to ensure that it is in python.title. But in this case, what we'll have to do for the title to ensure that it's in the correct format, we'll have to utilize regex. And what regex does is we're essentially providing it, and here I'm going to show it just because I'm a bit rusty on my regex, so this might be a little rough if I try to do it off the top of my head. But here is the regex. It almost follows the same exact syntax on every language with a couple of small differences. But the way it checks it is with the tilde sign. So it's going to take in the game title and it's going to evaluate it against the following regex. And this regex is ensuring that every word starts with a capital letter. And then after, it could be followed by lowercase letters between A through Z, or it could be followed by numbers between 0 through 9. And if I stretch this out, we can see that it accepts spaces in between each individual string, and it accepts hyphens and underscores, as well as a colon for special characters. And I think this is telling it to also accept apostrophes here. That's what and these are just escape signs. It's saying, hey, don't worry about this. I'm escaping the following. All right, so there's our regex. It's telling me that what it's able to accept. And then this plus money sign, it's saying that there may be words that come after each individual set of strings. So it evaluates the first word. After it evaluates the first word, it moves on to the next one, and it evaluates the second set of string and continues doing it. All right, so I'm just going to go ahead and rewrite this check here. Well, I'm not going to rewrite it. I'm going to actually copy it. Going to bring it over to my store, and I'm going to check it. So here we have my check where my game title should match the regex that has been provided to it. All right. And next we have our quantity. What constraints could we add to our quantity? Go ahead, Jens.
We could probably make that 4 decimals instead of, or sorry, 4 characters, digits instead of 5. And then check, was it less than 60 and then greater than 10?
Okay, so check if quantity is less than 60. I think
Sorry, I think I jumped ahead. Yeah.
Yeah, I think that
to price.
Okay, so we just want to make sure that quantity is greater than 0. Okay. So what else did you say you wanted to add to quantity? I apologize, I'm having trouble hearing you.
No, I think I jumped ahead to price. Yeah.
Oh, okay. So what did you have for price? So we got check that
it's
price.
greater than 10 and price is less than 60.
Okay.
And then I guess the 5, we can change that to a 4 instead for digits.
Huh. Yeah, you're right. Let's change that to 4. Okay. What else? Should we accept no values for price?
No.
Yeah, not null should be included.
So let's add not null.
I did have a question. It didn't matter whether the check came first or the not null came first.
Doesn't matter. I don't think it does. We can try it out and see what the syntax error, if we get a syntax error.
Okay.
Let me actually go ahead and add this not null as well up here. Okay. And just to follow the same syntax that I have everywhere else, I'm going to go ahead and tone it down. All right, so now we have our game ID with an integer primary key, or game title, or unique, not null, and it checks that it has the correct regex. We have a quantity where we check that it is not null and that the quantity is always greater than 0. And then we have our price where we make sure that the price is greater than 10, but less than 60. All right. Let's run this. So if I run ls, I can see that in the current directory that I'm in, I have my data and my store. I'm going to go ahead and make sure that I can back into data and into the game CSV. Okay, perfect. Let's go ahead and run this command. Okay, so it looks like everything ran correctly. All right. I just got a bunch of notices because those tables weren't created before, but the table for my game was dropped, and then I created the table, and I was still able to successfully copy all 10 entries. So now if I go over to SQL, into my PostgreSQL terminal, I can go ahead and run the same query and I get my same amount of tables. I ran select all from game. I can see all of my game ID, quantity, and price was accepted. If I tried to add another entry, let me go ahead and do that. Let's go into my game CSV. Let's try to add another entry here that violates all of my constraints. Quantity is 0 and the price is 60.99. So let's look at one each time, one at a time, right? The first one that's going to fail should be my serial primary key. So now when I run this, okay, so I get a error. When I run into this error, we can see a new for relation game. Okay, so it violates a check constraint for the game price check. So it looks like the first one that threw an error was my game price check. All right, so failing row contains failing check on copy and passing it the series of string. Okay, so that's because it didn't meet my actual check to ensure that it was less than 60. If I turn this to 59.69 and I run it, well, now I get another one. This one is saying that the game quantity is the problem there. So it goes into it. It tells me, hey, there's a violation in game when I tried to copy this data. I have a constraint telling me that I can't accept 0. So now what happens if I turn it into 1? Well, now I get another problem. And my next problem now is going to be my game ID. So it looks like my game ID is equal to 10, but it already exists. So it violates the unique constraint for a game primary key. I never gave it a unique constraint. It is just a serial primary key, but it knows that that ID already exists and that IDs are supposed to be unique. So let's run that. Okay, and that seemed to have worked, which tells me that my regex is actually wrong. My regex allowed this Final Fantasy entry to actually go in, which it shouldn't have.
I can help with that really quick, Francisco. Go
Oh,
back to your regex.
Yeah.
Okay, in front. So that whole group right there will accept any one of those characters. So insert right after your caret, another bracket group. Close the group and put capital A to Z inside that group.
I see. So this is
Now that's the first character because everything else there after that is going to match any one of those characters in that group.
perfect. All right, let's try it out. Duplicate key values. Oh, did I forget to change it back? I did. Apologies. Okay, great. Yeah, so there we go. We get our game title check, which failed. Appreciate it. I think that was DJ. Thank you so much. All right. So now we can see that our relationship here failed at game with the game title check. The row fails, and it fails because of the F in Final Fantasy. Now, if I make them both the same thing, they have the same exact name, and I run it, well, now it's going to tell me this is supposed to be unique, and you're giving me the same name for both of them. So let's go ahead and make this remastered. Let's make sure I don't violate any other constraint. And there you go. I was able to grab all 11 entries without violating any of my constraints. So let's take a look here. Let's say select all from game. We should see it as our final entry. We have entry 11 with Final Fantasy 7 Remake Remastered with a quantity of 1 and a price of $59.99. All right. Does anyone have any questions regarding constraints, how to apply those constraints, and how those constraints raise errors? Any questions regarding any practical application with constraints? Go ahead, Jose.
I just wanted to ask, so like in terms of this ID, the game ID, where you chose int instead of serial. Can you go over the command that you put at the end, like if you were to enter more data without an ID, so it catches up?
So game ID, because has integer primary key, what would I do for entering more data? And what
Without an ID?
without an ID? I don't think you can if I'm utilizing just integer ID. But I'm pretty sure I can do here. Insert game. And then I could enter the fields where the game title. And this is me assuming may completely be wrong. My quantity 2 and my price 10.15. Syntax error at or near game.
Isn't it insert into?
I think it might be. Thank you. Okay. So you don't like that, I'm assuming? Let's see that one. I'll have to get back to you as far as the insert command. That's going to be covered tomorrow in our queries lecture and how to insert and alter data as well as adding indexes. But I'll cover that here shortly. I apologize today. All right, next is yams.
I had a question about when we fail the checks. Does it create the rest of the table, or does it just not create anything until that check is passed, until all checks are passed? Does
Yeah.
it skip over? Yeah.
That's definitely good. That's a good question. Let's go ahead and try it out. Let's move our Final Fantasy entry up here. And let's go ahead and make a cut at 60.01. So we're going to check if this will throw an error, which it should once it fails that check. And then we'll see if the entries for 6, 7, 8, all the way down to 10 will still be entered. So I'm going to go ahead and run my SQL file. And now when I run my select all query, we can see that none of it was actually entered.
Okay, thank you.
Yeah, of course, no problem. So here it gives us a little bit of context. So it tells me, hey, I'm going to go ahead and it dropped my table. Then it created my table for game. But when I checked it, it can see that my game violates the game price check, felling row, and then it just never copied the rest of it. All right. I see a couple of questions in the chat here. So with regex, is it wrong for me to think of plus as a repeat sign in music and the money sign as a coda in music? Trying to tie it to something I already know. I don't know music, so I apologize for not being able to answer that question.
Okay, the $ means the end of the line. The
There you
plus means one or more matches.
Is that along the same lines as what you're trying to compare it to, Nika?
I was thinking the plus sign to repeat, but that makes sense. Okay, thank you so
it
much.
matches whatever's in that group one or more
Okay.
times. A star would match it 0 or more times, I think.
Okay.
Yeah, let me double check that.
Okay, thank you. I appreciate it.
There you go. All right. So now, would you say it's common practice to have the ID of the table be called ID or table name underscore ID, or which is considered best practice? I think that's definitely one up to you. But two, I would always do table name underscore ID. The reasoning behind that is for when you start creating references, you want to make sure that you're making those references and those foreign key relationships to the correct table. It's just an extra layer, right? People know which table it is that you're calling and then attaching that ID. And Landon, I think you have a question or you want to iterate on it?
I was just going to add to exactly what you were saying. When you start doing joins on IDs and you start writing queries, it won't allow you to have the same column names over and over again. So if you have multiple tables that you're joining on and they're all like ID, 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 and you roll that up into a query, you actually have to end up giving the IDs aliases because it can't return 3 columns with the same ID or the same naming convention.
Perfect.
Okay, that makes sense. Thank you, guys.
Of course. All right. I think your hand is still up, Lyndon, but I'm pretty sure you don't have a question. Awesome. All right. Does anyone else have any questions regarding constraints, and the checks, anything that we covered during part 1 of the lecture? All right. The final constraint that we're going to be covering, or that we'll just talk about quickly, but we won't actually go into it until part 2 of our lecture, is going to be the foreign key constraint. So the foreign key constraint is what it enables us to actually reinforce relationships from one table to another. Now, again, we'll cover this in part 2 once we start making relationships. But let's say I had something like genre. All right, let's say I created something. So create table genre, and I have a name, which is just a varchar, and I'm going to avoid adding all the other constraints here. Let's say unique, not null. And then after that, we have our genre ID, which is a serial primary key. Okay, and let's say we just have that. All right, well, if I wanted to connect the two, I could say that my game has a genre, and I could say that this is an integer. All right. So technically speaking, I could say or join these two tables right up above where the same integer in genre matches the genre ID, right? But it's not actually being enforced. When I run this through SQL, whether that data exists or not, Postgres won't actually make sure that this is a good relationship or that I have a good integrity in there, that the data exists and that I'm not making a relationship to the wrong table, to a primary key that doesn't exist, or just making the wrong assumption overall of how I'm connecting these relationships. All right, there's a couple of different problems that you can run into when you're making those relationships. Well, by adding the foreign key constraint, I created that genre, and maybe I want to be more specific here and do something like genre ID. Well, when I come down, I can look at the real world scenario and we have these employees, and let's actually specify using this. So we can see they have something similar. They have departments where they have the department ID, the department name. They create a table for employees where the employee has an ID, the employee has a name, but then we have a department ID. Again, that's not being enforced up to this part. There is nothing telling or reinforcing this information or actually checking that this is a valid entry of data. But by adding the foreign key constraint, we are telling it, hey, I want you to check that department ID, the input for this department ID, is a valid reference to the table departments for the field department ID. So now when somebody enters 1 into this entry, it's going to go over to departments, and it's going to check that within departments, inside of the department ID, there is an entry of 1. And if that 1 exists, then it will run the data correctly and create the relationship. If it does not exist, it will throw an error without enforcing the relationship. So the relationship could be created without the foreign key. The foreign key constraint is what enforces and checks the said relationship. Does anyone have any questions over the foreign key constraint? We'll go over into practical application during part 2. Oh, go ahead, Jens.
Must foreign keys always be not null, or is that not necessary?
Will foreign keys always be not null? No. So if you want to add any sort of other constraints to the foreign key here for the department ID, you can add it just as if we did over here. We could add a check, we could ensure that it's not null. But the foreign key enforces the relationship and nothing else.
And then one more question for the foreign key. I see that's at the bottom. Is that necessary because is that specifically because it's already pre-populated? And so when you're adding in data, if it's placed, say, right under primary key, it might be confused for the first entry that you put in.
I see. So why would it be at the bottom and not before? This foreign key constraint should be added after the department ID has been created. If department ID is created after the foreign key constraint, it's going to throw an error. As long as it's after this line, it doesn't matter where you place it. But it is common to place it at the bottom because that's where you would want your references to be at. Does that answer your question, Jens?
Okay, yes. I see, I misunderstood the, because you actually do explicitly give the apartment ID that you want that entry to be connected to. So that's not going to be automatically generated just because the departments table has its own primary key, right?
Exactly. Yeah, you're passing that in manually. All
Okay.
this is doing is enforcing that relationship is valid.
Okay, thank you.
Of course. Brian?
Kind of related to Yams, the documentation for Postgres looks like the department ID int can be a single line. Continuing after department ID int, just say references department's department ID. And that looks like valid syntax as an alternative to specifically listing a foreign key constraint under the department ID int. I was wondering if you've seen that, or is there any real difference between the syntax?
Yeah, so I think that's just kind of like shorthand, right? It's still declaring the department ID being an integer within the table, and it's still doing the reference and reinforcing the reference. There's not necessarily a difference in functionality. It's just more syntactual. Awesome. I see a question here on the chat from Natalie. It says, if we have a foreign key relationship and we load data in from a CSV, and there are values for both sides of the relationship and they don't match, okay, will Postgres keep the CSV data entry, or will the foreign key relationship value be the new value, or will it be an error? It will actually throw an error and it won't run the copy command. So when you run the copy command, it runs through the data within the CSV, make sure that the data within the CSV is acceptable. And if the data within the CSV is acceptable, then it copies and inserts it into the database. So it runs through the CSV file first, validates data entries are good to go, then it puts it into the database. Otherwise, it won't load it into the CSV file, just like we saw earlier when we did that check constraint and we moved the Final Fantasy game to the middle of the CSV file and it didn't copy any of the entries. That's what the same thing that would happen. It would run into a foreign key relationship error saying that that foreign key doesn't exist. And then after that, it wouldn't run the copy command. Does that answer your question, Natalie?
Yeah, it does. I also have like a little quick question,
Yeah.
another one. So in your employees table where you're referencing the foreign key, I see you have like a comma after like int. Do you need to have a comma after your, like after you've declared that column name and you're going to use the foreign key, or can it be just all, together?
After I declare the column name and I
Yeah,
use,
because yeah.
so you're saying like this comment specifically, is it necessary, or could I indent this and have it all in one line?
Yeah.
So you can do shorthand where you establish this all in one line. But I would prefer it if for now we all manually write the department ID and then make our foreign key relationship for practices and to ensure that we're actually making that connection to the correct ID and correct field. Does that make sense, Natalie?
Yeah. Okay. Thank you.
Of course. Any other questions? All right, fantastic. If there are no other questions, I'm gonna go ahead and pause the recording here. Recording. All right, welcome back, everyone. I hope everyone had a good time with the first portion of our lecture and adding some constraints into our database. Next, we're going to be talking about relationships. But before diving into relationships, I would like to address a question that Jose asked us before taking off into our break. So we have our game here where we're utilizing a serial primary key. All right, and he had a question about, well, now that we have a serial primary key, how is it that we can insert more data without manually adding the primary key? So I ran into a couple of issues applying that. If we run our file here from store SQL and I run a select query into the database, we can see that everything's inputted correctly and everything works great. But if I try to run an insert into command of game, passing it the correct values, such as quantity. Oh, I need game title, I apologize. So game title, quantity, and price with the values of my game, quantity 2, and the price being 30. When I run this query, I run into an error. So it looks like it tries to create a key. And when it tries to create a key, it tells me, hey, the key of ID 1 already exists. So what's the problem? Well, if I take a look at my relationships here, and favorite game, yeah, if I take a look at my relationships here, I have this game ID sequence that's happening there. Well, if I run a select query, oh, I can see that it's still just at 1, right? It still only has 1 value inside of it, even though my current table has 11 entries. Okay, so when I tried to create that new entry where I didn't specify the game ID utilizing the insert command, it ran into a problem because it tried giving it the value of 1, just like it has here. And it said, well, that value already exists because that's what I copied from the CSV data.
Good, thank you.
Oh, go ahead, Jose.
Oh, sorry, I was telling Adrian because he was asking me about this earlier, so I was just like, hey, look, this is what we're talking about.
Oh, awesome. All right, so now if I run this, I run the P-SQL store, I'm dropping the table and creating the table, but the only difference is I'm not copying from the game data. All right, so let's run that select query one more time to make sure that my game is empty. Jesus, I cannot spell this morning, I apologize. So there we can see that our game is empty. We have no rows being entered into our database. And now I'm just gonna run that insert command one time again. So I'm running the insert command. I'm giving it the fields game title, quantity, and price with some values that will meet my constraints, but I'm not providing it a serial ID number. Well, now when I run this, we can see that that insert value actually worked. And when I run this again, I'm just going to go ahead and add a number 2 to my title to make sure that it fits that unique constraint. This seems to have worked. And one more time, 3. Okay, so all 3 of those insert statements worked. So now let's run select all from game. I can see all 3 of my games have been inserted. I never once provided that serial ID number, but it generated it for me automatically. And I can see that it adds up all the way to 3. Well, now when I run select all from game in the game ID sequence, well, now we can see that the last value that was called was 3. And it matches the last entry of my database, which was 3. So that's where the conflict is coming from. This sequence wasn't being incremented when I copied from my CSV file. So if I don't copy from my CSV file and I utilize an insert statement, it will automatically increment to ensure that I don't have any repetitive IDs, and I do not have to specify the game ID being passed in there. Did that answer your question, Jose?
Yeah, I had run into that issue, and so I'd seen that there was like a command to enter to like have it catch up to the latest ID whenever you hard code data into it. So that's why I was asking about it, like when and if we need to use that. But yeah, this helps. Thank you.
Okay, awesome. Yeah, we could definitely demonstrate that command later on. I'm gonna dive into relationships, and then afterwards we could go over that command as well as far as making the actual game ID sequence catch up to which one is the last one. All right. So now moving on into relationships. Let's go ahead and take a look at our nice view of the relationship lesson. And let's go ahead and comment out this table here. So relationships. What are relationships and why are they important within PostgreSQL? So relationships, we have three kinds. And in reality, what relationships mean is how does one object relate to another? So we think about object-oriented programming, or at least I think about object-oriented programming whenever I go to create a table, right? With each individual table being the smallest object possible and representing one specific object or entity. So how does that one object relate to others? For example, I'm running some sort of grocery store, all right, and I'm selling items. So I'm selling some sort of food market. Well, I have to create a way to manage all those transactions that are happening within items. So I can have relationships in my database that say, hey, these items are the ones that I have in my inventory. I have transactions that happen, and within there, I have a transaction item that works as a connecting table between all of my current inventory items, which connects to my transaction items, which then connects to an individual transaction, right? So following those steps, I can see how I need separate tables and how each one of them need to relate from one another. But how do I create that relationship within Postgres? Or how do I enforce that relationship? Well, that's where actual foreign key constraints come into play. And we're going to cover we're going to cover the three main relationship types. There is one-to-one. So if I'm thinking about a person, every person has one social security number. So there's a one-to-one relationship. There is a many-to-one. If we think about a person going to an airport, a person may have multiple suitcases. So there you go. Those suitcases is the many, where they all belong to one person. And then we have a many-to-many. Maybe a person is taking many airplanes. So many people board the same plane and many people board many airplanes. And there we have our many-to-many relationship. All right, we'll break this down in a couple of examples here shortly, but that's a quick introduction over what are relationships and why do we need them. Does anyone have any questions over that quick overview of relationships up to this point? All right, it doesn't seem like there are any questions, so let's move on to the next portion. In this portion, we have a one-to-one relationship, and it gives us the exact example that I just talked about, where an employee has a social security number, and there is a one-to-one relationship from one employee to one security number. So let's go ahead and actually start creating these tables. I'm going to start us off by making our create table context here, where I'm going to place the employee. And then I'm going to create table for a social security. Yeah. All right. So starting off with the social security, can anybody walk me through the two things that we would need to keep track of in the social security table? Go ahead, Brian.
It would be the social security number itself.
All right, so we'll do SSN And what kind of field do we want this to be?
How about integer?
Okay, let's make an integer field. All right. What else?
And then you want it to be not nullable. And unique.
Perfect. So now we have all that information that will work. And let's not forget our social security ID, which is going to be a serial primary key. Awesome. Thanks so much, Brian. Can somebody else walk me through creating this employee now? Let's just say that we just want the ID, name, and then a social security number. How could we make that happen?
Would the serial primary be the ID?
All right, so let's start that ID. Let's do employee ID, which is a serial primary key. All right. Let's go ahead and add that employee name. And what would we want this to be?
That'd be a varchar.
Okay, let's make our varchar. Let's just make it 9 characters. Do we want this to be null?
Not null.
All right. And this, would this be unique?
No.
Awesome. So now we have our employee name where it will not be unique, and we are not going to accept an empty entry. And next we'll just say SSN ID is an integer. Okay, that's what we'll finish it off for now. All right. So we were able to create these 2 tables. Well, how do I relate one to another? I know that there's supposed to be a one-to-one relationship. For every entry of an employee, I have to make sure that there is an entry for a social security number. So let's go ahead and add our not null context here, and let's create our foreign key constraint. So I'm going to go ahead and explain foreign key. I'm going to tell it that the foreign key on my current table is SSN ID, and that I want it to reference to social security table on this. And let me just go ahead and enter that on the social security ID. Okay, so there we have our create table statement. We're going to grab a social security with a serial number ID, and then we'll go ahead and create some data in here. So let's go ahead and create a social security. There's 3, there's 4. All right, there you go. 10. So now we have one social security, and now we can insert into employee, where we're providing the employee name and the SSN ID. Now we could do the values of, let's do employee name. Let's just use myself, or let's use Adam since he isn't here. And let's go ahead and pass in the SSN ID being 1. All right. I just used option Z to wrap everything up. I'm not actually making a new index. So now I have this file. It's going to be able to create a table for Social Security, and it's going to create a table for employee. All right. Well, let's run this SQL file. And I'm just going to make a new table here. So create DB, example DB. All right, looks like that worked. So now I'm just going to go ahead and run it into example DB. Okay, so it looks like it worked. It was able to create a table and it was able to insert twice. It grabbed data from both of them. So let me go ahead and connect over here to example DB. And now let me run a query for select all from social security. We can see that we have one social security entry with the ID of 1 and the security number that we provided. All right. If I select all from employee, we can see that the employee has the ID of 1. The name of the employee is Adam. And the social security number that I reference to has the ID of 1. And that is how we create a one-to-one relationship. Now, there's nothing actually enforcing that this is only a one-to-one relationship at the database level. It is only for developers to be able to enforce that. It is up to us to enforce this sort of relationship, recognize it, and ensure that when we create our database schemas, that is what's actually happening. We can't actually enforce the one-to-one relationship. All right. Well, now let's go into something that we were briefly talked about yesterday. Let's go ahead and drop a table if exist, and let's make that social security. Well, I wonder what happens when I run this file. Let me go ahead and open up my terminal here. All right. Well, it looks like I got a it looks like I got a problem when I tried to create my table. So it tells me it cannot drop a table social security because other objects depend on it. Constraint employee SSN F key on table employee depends on table social security. So it tells me that inside of employee, there is a field named SSN ID that depends on the table social security. So it tells me, hey, you can't just drop this table. You would have to drop the employee first before you can drop the social security. And I could do that, right? Let's say I do drop table if exist employee. And then I run it this way. So that works. But there's a small problem when I do something like that. Let me go ahead and run this all over again. Okay, that works. I think that works. Okay, so currently I have my social security number and my employee placed in, all right? But now let's go ahead and remove this insertion of the employee. And we still want to drop the table if it exists for the table social security number. I mean, for the table employee. Now let's run that. I'm not sure why I'm getting this duplicate key error here. Oh, it's because I'm trying to create a table. I apologize. Well, now let's take a look here. If I look at my employee table comes out with 0 rows. But if I look at my social security number table, that comes up where there is still a social security. That causes a problem, right? Because I don't want these dependencies to just drop. We know that this has a relationship. So if my employee is removed, I would want the social security existing for that one employee to also be removed. So how could I fix this? I can't just switch it back up, right? Because we know that that's going to create an issue. Well, what I would do is I would drop social security if it exists, and then I would add a statement named cascade. And what cascade does is it kind of, I don't know why, but whenever I hear the word cascade, I just think of a waterfall, right? When I drop Social Security, it's the domino effect starts happening. Anyone who is depending on Social Security will also be dropped. So let me go ahead and delete this statement here. And I'm gonna go ahead and, well, let me fix it first. And after I fix it, then we'll run that statement. So I'm gonna go ahead and fix the file. I'm still getting duplicate keys for some reason. Let me see, drop table would if exist. Oh, there we go. All right, so now I fixed the file. It has all the information that I provided. If I grab from employee, I have one entry, and I have one entry from Social Security. Well, let's see what happens when I ask Cascade. I'm just going to comment the rest of this file out. That's all I want to do. I want to drop the table if it exists, Social Security, and I want to send a Cascade statement into it. So now I'm going to go ahead and run this SQL file. Okay, so we see drop table cascades to constraints employee Social Security number ID on table employee, and it dropped the table. Well, now let's see what happened. Let me take a look at my relationships now. Well, now I still have my employee table, but notice the Social Security number is now gone. If I select all from employee, I still have everything and the relationship seems to still exist, which is a problem. So maybe there's a different argument I could use here. Wonder what happens if I utilize drop. So I'm going to go ahead and fix my SQL file one more time. Going to go back into commenting it all out. Again, if I take a look at my employee, everything is there. If I take a look at the Social Security, all the information is there. But now all I'm going to do is I'm going to drop the Social Security number with the keyword drop after it. I wonder if this will raise a syntax error. Okay, so raise the syntax error. I can't do something like that. So I have to utilize Cascade. By utilizing Cascade, I'm not necessarily getting rid of the next table, but what I'm doing is I'm getting rid of that relationship or that constraint. I'm telling, hey, this constraint no longer exists for this specific entry, and I'm dropping the table of Social Security. So now if I go ahead and I make all of these dependencies all over again, I'm going to drop all of the table, run the cascade. So now we can see that I was able to drop the table. Everything cascaded correctly. It dropped the table, created it, dropped the table for employee, and created it again. And everything is back up to speed. All I did was add the cascade argument to be able to drop said table when a relationship depended on it. Does anyone have any questions over cascade or building a one-to-one relationship? Go ahead, Jose.
Is there another function that actually deletes or gets rid of the other ones, or is it just only to remove that link or that foreign key connection?
I believe there is something that will be able to drop it completely. I don't know it off the top of my head. Let me see if it's somewhere in our curriculum. But I believe there is something that will drop it completely.
Okay.
Let me see if Sentinel will be something that it will take in. So if I do this. I don't think it's going to work, but I'm going to try it. It didn't work. I have to get back to you with that correct command. Okay, everything worked there. I see a question on the chat saying, would it ever be appropriate to just use the social security number as a primary key since it's unique and wouldn't be updated? Or should you always use a serial primary key? That's a great question. So you can actually utilize something other than a serial primary key. If you wanted to make it a social security number, I wouldn't do that because you would be exposing that person's unique social security number. Maybe like if you have something like an employee ID that's a mixture of numbers and characters, then you could do that. But then you wouldn't use a serial primary key, you would just use a primary key field. Does that answer your question, Crystal?
Yeah, and then you would just use like that employee ID as the foreign key.
Yes, if you wanted to make a relationship to that employee, you would utilize that employee ID.
Okay, makes sense.
Awesome. All right. So now that we've gone over a one-to-one relationship, let's go over, oh, look at that. Let's take a look at the example. So here we have our employee, which has a serial primary key, and then we have a social security. They built the relationship the other way, where the social security has a relationship to the employee, and the social security is added in that way, where I did it backwards. I made it from social security to employee. All right. The next one is going to be passports in person. So consider a scenario where each person holds a unique passport. This one-to-one relationship between persons. So every person has one passport, just like every person has one social security number. Let's take a look at the table they provided as an example here. So there we see our create table, takes in the person name, and we could see the passport. And again, that foreign key relationship, this first person ID is in reference to the one within the table. And then it has references to the person's table for the entry for person ID. Right, so the first argument is for the same table. The second argument is the table and the field within said table. And then we have one last example of cars and vehicle identification numbers, so VIN numbers. We can see that we have the cars here being created, primary key and a car model, any other details. And then we go into the VIN where we have the car ID and the VIN. And I think this should be VIN ID, because this is trying to utilize the car ID as a serial primary key. So this table has a syntax error. I apologize to everyone. This should be VIN ID. There should be an entry for a car ID saying that it's an integer, and then that car ID should then have a reference to. All right. And then we just talked about Cascade, when and why to use Cascade. And the next relationship that we're going into will be many-to-one. But before moving forward, does anyone have any questions about any of the things that we've covered so far? Okay, so we see a question on the chat from Natalie. We see, how common is it to have multiple foreign keys in one table? If you have more than one, you want to keep your relationships as simple as possible. It is common, and you could have more than one relationship to one table. So for example, right now, let's say we just went over the person example, right? And we talked about the social security. If this person's going through an airport, maybe we can also have a passport table being created. And then this employee or this person would also have a foreign key relationship to said passport. It just kind of all depends, but you want to make sure that if you keep your objects as small as possible, those relationships should make sense and they should be quite simple to make. But it is common to have multiple relationships within one table. Does that answer your question, Natalie?
Yeah, thank you.
Of course. All right. Let's push forward into our many-to-one relationship. So our many-to-one relationship, we have students and a university. This is pretty simple. So many students belong to one university. And we're going to see that in the following examples, the syntax is going to remain the same. Again, nothing is going to reinforce the relationship of many to one. It's all more on the visual side for us to make sure that this is happening. So let me go ahead and kind of make a visual here. So a 1-to-1, that would be our relationship. And a many-to-one would be something along these lines. Right, so there we would see the many different entries being on the left side, and they connect to one. So let's make an example of that. Our many to one, we have this relationship. Oh, hello, where did we go? Cascade, there we go. Many to one, we have this relationship between students and university. For time's sake, I'm gonna go ahead and take this one over. Gonna comment all this out. I'm gonna go ahead and create table school. This table should have a school ID. And the school ID should be a serial primary key. All right. I should also have a name, which should be a varchar. Let's make it 15, not null. And let's make it unique. All right. And I think I'm going to keep it there for the simplicity's sake. And now let's go ahead and create a table named students. Forgot my semicolon there. Okay, so now we have student ID, which is going to be a serial primary key. And we should have a student name. And let's say student, I would add student email and all that stuff, but for simplicity's sake, I'm just going to go ahead and put other details here. And then finally, I'm going to go ahead and add my school ID. So let's say school ID. And now that should be an integer. It should not be null. And I'm going to go ahead and make a foreign key reference to from school ID, where it's referencing school at school ID. And that should create my relationships. All right. So now let's go ahead and make a couple of entries here. So I'm going to insert into school the values of school name. So what I'm going to go ahead and insert will be let's see, Garfield. I'm sure that's a common one. Okay, so now I'm going to create those two schools. And let's go ahead and insert some student data now. Right, so there we have Francisco going to school 1. We have Adam going to school 1. Let's have Zainab going to school 2. And let's have Raphael going to school too. Okay, so there we go. We have two schools, and each school is going to have two students. So let's run this relationships. I can see that I have a syntax error somewhere. Let's see. Well, I have a syntax in a lot of places. So, oh, it's right after this insert. Insert into student. Relation student does not exist. Create table student. What am I missing here? Line 4. Here we go. Have a comma there. No comma. That's good. All right, let's try that out. Okay, so that worked for students. That was able to get students in. And now I have another syntax error. I'm assuming this is here. Foreign key, school ID, integer not known. References to school. Let me see, am I messing up the foreign key syntax? I am. That needs to be wrapped in parentheses. All right, there you go. Duplicate key values. Okay, so that's fine. That's because of my site. All right. So now if I do my \d here, I can see that I also have a table for a school. And I have a table for student. It looks like I don't have a table for student. Did I name it something else? Oh, I apologize. It's right down there. Okay. There you go. Here's student. So here's my student and here's my school. Okay. So now if I run select all from school, we can see that I have two entries. If I run select all from students, we can see that I have 4 entries, but each one of those students is referencing to the correct school. I have many students, which is more than one, referencing one school. And I just built my many to one relationship. Does anyone have any questions about many to one? All right, doesn't seem like anyone has any questions over many to one. So let's take a look at the curriculum and make sure that we did make that relationship correctly. So we can see here we have our university with a university name, our student that has a student ID and a name, and we can see that reference over to the school. Great. We have a couple of other examples where we're talking about customers. So in this scenario here, we have consider a business where a business context where customers are associated with countries. So this is a many to one relationship, again, where many customers are associated to one country. Here we see the country being created and the association happening from customers. All right. And now we see employees in department where many employees can belong to one department. We see the department being created. and our employees with a many-to-one relationship to that one department. Okay. That's going to be it for many-to-one question. I mean, our many-to-one relationships. And next, we're going to go ahead and move into our many-to-many relationships. I apologize, everyone. I was looking at the chat, making sure I was up to speed. Okay, so now here we go, many-to-many relationships. So students in courses. In an academic scenario, a many-to-many relationship exists between students and courses. Students can enroll in multiple courses, and each course can have multiple students. So now we can't handle that doing what we've been doing so far. We can't just say, hey, this works, this is all I wanted to do, right? We would want to actually create a connecting table. We can't just call the foreign key relationship within the same table. If we call the same if we do it within the same table, then that would mean that we would have some sort of many-to-one or one-to-one. But in order to create this many-to-many relationship, we would do something like create student. Let's have this student have a name. So student ID takes in a serial primary key. Let's have a student name. This should just be a varchar that has 20. That's going to conclude our student. And then let's create a subject. And let's just do subject. Oh, subject might be a keyword, so maybe we don't use that. Let's use course instead. So let's do course ID is serial primary key. And let's do course name. Again, a varchar of 20. Maybe we can make this unique and not null. Same thing up here. Let's just make it not null. So that creates our two tables. But how do we connect them? Well, I think yesterday someone had a question about a junction table. That's we're not going to go into how to do join tables or generate join tables with SQL queries just yet, but we're going to go over how to create this many-to-many relationship, right? We just covered how we could do many-to-one. So many students can have many courses, and many courses can have many students. So what we're going to do is we're going to create a third table that will say course students. This will also have an ID. So let's do course students ID. This will be a serial primary key. And then we'll create their relationship to the student table and the course table. So first we'll say student ID will be an integer. We'll say course ID will also be an integer. And then we'll create our foreign key relationship from students ID, where it's going to reference the student table for the field student ID. And then we'll add our secondary relationship for course ID that will reference the course table at the course ID. And that will create our many-to-one our many-to-many relationship. Many students can have many courses, but they don't necessarily have a connection between the two of them. They have a midway connection, right? So if we were to take a look at our example here, here's our many-to-one relationship. Well, our many-to-many would look something like this. where everything is just being inverted, right? We have many on the left side going to one single connecting table, and then the many on the right side, making it a many to many relationship. Students would be on the left side, course would be on the right side, and this core students would be the center zero here, creating that many to many relationship. Does anyone have any questions regarding many to many relationships or how we could go about creating them? Go ahead, Louis.
I was two questions. One, you just have create for all the tables and not create table.
Yep.
I was just curious. Okay. And then my second question was, I was looking at it with the curriculum for what we have here, and they do their primary key as student ID and course ID. What would that do rather than like they're just using it looks like they're using a combination of a student ID and a course ID to create their unique primary key for that table? I was just wondering like pros, cons, and the differences.
Let me take a look here. Student courses, student ID, course ID, primary key, student ID, course ID. Interesting. Yeah, let's take a look at what that looks like if we add that in there. Primary key, student ID, course ID. Okay, let's go ahead and get rid of that connecting table there. We have our foreign key relationship still working. So let's try to insert some data so that we can see what's going on. All right, so all we need is student name and course name. So insert into student, oh, where all I need is student name with the values of all right, and then let's make some courses. It looks like all I need is course name, I believe. Yep. Let's do Python, JavaScript, SQL, and finally, let's do OP. Okay, so there we have our 4 courses and 4 students, right? And we're not going to make a course ID, a course students just yet. I'm going to go ahead and drop this DB because it has too much dirty data at this point. Okay, so now I was able to drop it. We can see that I have no relationships inside of example DB. And now I'm going to run this SQL file here of create students where I'm going to insert all of this data. Seems like I have a couple of syntax error here. Let me see what's going on. Oh, I put values instead of value. I put value instead of values. It's always the little things that get me. All right. Try that again. Insert into course, course name. There it is. Okay, let's. All right, I apologize. Just had to do a little bit of cleanup to get that all working correctly. I think now I have it. Let's check it out. All right, there we go. So now I was able to create all of my courses, dropped all of my tables and create all of my tables. I have nothing but notices. No error. Oh, I do have one error. Course student already exists. Well, that's okay. So it didn't run this one, but it still had everything. Just in case, let's do. There it is. No errors, just warnings, if any. All right. So now we got all of our insertions. If I run \D, I can see I have my course ID, course students, and students. Well, let's select all from course. There's all of my courses. Select all from student. There's all of my students. Now let's select all from course students. Well, now we can see that there was no primary key associated to it. What it's utilizing as the primary key is the actual relationship between the two. All right, so if both of these exist, that's what will be its primary key. And that's how it knows it's not going to actually have a primary key existing inside of it. It's not going to provide me a field for primary key. But when I run join tables, I can utilize this table to join by reference to my own student ID or my own course ID, which we'll see tomorrow. So let's insert some data for this relationship now. So let's insert into course students. And all I need is student ID and course ID. So student ID, course ID. I'm gonna pass in some values here. Let's do 1, 2, 1, 1, 1, 4. Let's do 2 and 2. 3. Let's do 1 and 1. Oh, I already did 1 and 1. Okay. Syntax error, insert line 2, student ID, course students. Let's see. That or near insert. So I forgot to put my semicolon there at the end. There you go. So now everything was added into my database correctly. And now if I run that same query, I can see that I have all of those relationships that I had before between student ID and course ID. Now I have relationships where the student of 1 is taking the course 2. He's also taking course 1, taking course 4. Student with ID of 2 is taking course 2, and that's it. But notice that course 2 also has student with the ID of 1 and the student with the ID of 3. We're making a many-to-many relationship where many students can attend many courses and many courses can have many students. Did that answer your question, Lewis?
It does, yeah, thank you.
Of course. Go ahead, Adrian.
So for the many-to-many relationship, that has to be like a separate table. I guess to me it makes a lot of sense when it like visualize it in the terminal there.
When you visualize in the terminal like this.
Yeah, is that just the way it's done?
Yes, you would have to make it a separate table. Later on when we go into Django, there's going to be a way where we could do a many-to-many relationship without creating a separate table ourselves. But it will still create this connecting table in the background for us, and it'll manage the connection for us. But this connecting table will always exist to create a many-to-many relationship. Does that answer your question, Adrian? Of
Yeah, it does. Thank you.
course. All right, it doesn't look like there are any other questions, so let's go ahead and push forward here. We have this actors in movies example, where many actors can be in many movies. Again, we create a table for actors. We create a table for movies. And then here we have our actor movies, where we have our actor ID or integer ID, which are set as the primary key. And then we have our foreign key references, one to each individual table. Finally, authors and books, where many authors can write many books and many books can have many authors. We have our table for authors, a table for books, and then a connecting table where we are connecting authors and books. All right, and that is it for relationships. At this point, we've covered constraints, what are constraints, why we utilize constraints, the different types of constraints, and relationships, one-to-one, many-to-one, and many-to-many. At this point, does anyone have any questions over any of the topics that were covered today? Go ahead, Jens.
Sorry, just real quick. When it came to I think it was one-to-many relationships, is it the many that has the foreign key, or was it the one table that has the foreign key as far as relationships?
Many-to-one, many will be the one that's holding the key, whereas one will be the one that's being referenced to. That's a good question. All right, if there are no other questions, I'm going to go ahead and stop the recording now.